So for the functional group notes, we're going to be filling in this table. So I'm going to go back and forth between zooming in and zooming out, just so that it's easier to read across the top. Now you're going to notice at the very top up here, it says each of these functional groups takes numbering or like nomenclature priority over alkenes, alkynes, halogens, and alkanes. So that means that these are in order. I put them in priority order. So carboxylic acids are the top priority when it comes to naming. All of these functional groups will take priority over alkenes, alkynes, alkyl halides, and just alkanes. So these will go in order. And so what we're going to do as we fill this out, we're going to just do a quick review of the functional group structure, the general structure, the ending, and then we'll look at the naming rules, and then I'll move it over and we'll look at an example molecule with its name. So we're going to start by looking at a carboxylic acid. Now, I started doing this in my packet on accident, so here we go. The structure, general structure of a carboxylic acid is that COOH. So remember, an R group is just any carbon group, but then you have C double bonded to an O, bonded to an OH. If you just see the chemical formula, you'll see that just as COOH. The ending is oic acid. So if you see something like methanoic acid, that OIC acid tells you that it's a carboxylic acid. Now, when it comes to the naming rules themselves, we're going to go through, we're just going to write out the naming rules. So, the carboxylic acid, carbon, is always number 1. So that carbon that's part of the carboxylic acid is always carbon 1. Then we number our parent chain. So then we find the longest chain that contains the carboxylic acid. So start by numbering your carboxylic acid, carbon number 1. Then you find the longest chain containing the carboxylic acid. So the longest chain has to contain that COOH. When it comes to the ending, so we're going to replace the E with oic acid. And I'll show you in the example what that will look like. So we replace the E. If it was methane, it's methanoic. Butane would be butanoic. You just drop the E and you add oic acid at the end. And then any substituents. So substituents are named like alkane nomenclature. So any substituents will be named just like alkane nomenclature. So you want to make sure your substituents are numbered correctly. You're alphabetizing them, not putting them in numeric order. It's going to all go back to the alkane nomenclature that we started with. So for the example molecule and its name, I just picked some random molecule for each one of these, but it just gives you an idea as to what it would look like. So I'm going to actually draw the structure itself. So let's say that it looks like this, OH, double bond O. And then let's add a couple methyl groups in here. So there's an example molecule with numbering. So the carboxylic acid carbon is always carbon 1. And then we look for our longest chain. Longest chain would actually turn sideways. 1, 2, 3, 4, 5. So when you name this, what's the prefix for 5? Pent, right? And 5 carbons all single bonded would be pentane. You drop the E and you add oic acid. So the parent name here would be pentanoic acid. So the parent chain, right, or the parent name, if I kind of write it over here, would be pentanoic acid. Now you still have to make sure that you're numbering your substituents and you're naming your substituents. We can't forget about those. What substituents do we have here? Right? We have 2 methyls on carbon 3. So we have dimethyl. Make sure if you have 2 methyls, you give 2 numbers. So it would be 3, 3, I always do that, dimethyl pentanoic acid. I'm going to write it better down here. 3, 3, dimethyl pentanoic acid. So dimethyl pentanoic is all one word, and then a space with acid. Carboxylic acids are the top priority when it comes to naming. Then we come to esters. So again, the general structure for an ester we looked at in the do now is that you have that carbonyl carbon single bonded to an oxygen, and then there are 2 R groups. R groups could be anything over here. This cannot be an H though, because if this is an H, it becomes a carboxylic acid. So you have 2 carbon groups off of the carbonyl carbon and off of that single bonded oxygen. The ending for an ester is O8. O-A-T-E. O8. When it comes to naming esters, we go through. We are going to start numbering from the carbon bonded to the ester group. Bonded to the ester. We're talking about the carbonyl carbon. So you start numbering from that carbonyl carbon within the ester. And then when it comes to an ester, there's actually 2 parent chains. So we're going to have 2 parent chains. And when we name them, they're separated by a space. Separated with a space. So, first parent chain is the parent chain off of the single bonded oxygen. Parent chain off of single bonded O. So the one off the single bonded oxygen is named normally. So named normally with the YL suffix, that YL ending. Like methyl, butyl, pentyl. So we actually named the entire thing like you would name an alkane, and instead of the A-N-E ending, you add YL. We'll look at it in the example molecule. And then the second parent chain is the parent chain opposite the single bonded O. So the parent chain that's opposite the single bonded O, you're going to just name with O-A-T-E ending. Named with O-A-T-E suffix. example would be methanolate. So esters kind of have a complicated naming system. We'll look at it in the example molecule because there are two parent chains. You're going to have the parent chain that's over here off the single bonded oxygen. Then you're going to have the parent chain that's over here that has kind of on the side of the carbonyl carbon. So if we look at an example molecule, I tried to make kind of a long one for the example molecule. Let's see if I can draw this. So I did this, carbonyl. So there was this, and then I did a couple substituents just so you could practice looking at those substituents as well. So it looks like this. Now this is where I'm going to number with two different colors because we have two different parent chains. So the parent chain off of the single bonded oxygen, that is over here. Just name it like normal. Right, name it like normal. When you're numbering, start the 1 with the carbon that's connected to that oxygen. So when I number, I'll have 1, 2, 3, 4, 5. Now if I were to try to name this like normal, just the pink, what is 5 carbons all single bonded together? Pentane. Alright, so we would have pentane at the end. Let's think about the substituents right before I write anything down. What substituents do we have off of this? Okay, ethyl and methyl. Which one's going to come first when naming? Ethyl. So I'm going to start with that. Off of carbon 3 is an ethyl group. So I'm going to have 3 ethyl. Then comes methyl. 2 methyl, and normally we would just say pentane. But if we look back at the naming rules, we name it normally, but we put YL at the ending instead of ANE. So it's going to be 3 ethyl, 2 methyl, and instead of pentane, it's pentyl. 3 ethyl, 2 methyl, pentyl. And then the second parent chain is this parent chain that's opposite the single bonded O. Now I'm going to number 1, 2, 3, 4, 5. Notice how both of the carbon 1s are on each side of the oxygen. 5 carbons again is what parent chain? Right, pentane. But if we look at the very last rule here, the parent chain opposite the single bonded oxygen is named with O8. So instead of pentane, it's pentanoate. So I'm going to put a space here. Pentanoate. If there were substituents off of that, we would keep naming our substituents. It would just be 3-ethyl, 2-methyl pentyl, and then you continue with the substituents before pentanoate.
So if there are substituents on the O8 side, you don't put a dash between the two names, it's just only a space. Between the last side.
Yes, yeah. Yeah, you'll have a space between your two parent, like your two sides. You'll always have a space in between your two sides. And we'll continue to look at practice. Esters, right, with the two parent chains can get a little tricky, so we'll keep looking at those. The next substituent that we look at is an amide. So an amide, we have the R carbonyl carbon with nitrogen. The ending, it's a nice easy ending, it ends with amide. In amide, the ending is amide. Remember the difference between amide and amine? Amide has that carbonyl carbon. Now, naming. So those naming rules with amides. We're going to start numbering at the carbonyl carbon. So start our numbering at the carbonyl carbon. We're going to name it as normal. We're going to designate our substituents. All right, name as normal. I'll just put designate substituents. Meaning, based on your numbering, what are your substituents that you have connected? Where it gets a little weird with amides and amines, if you looked at that functional group intro, you saw some of the molecules had an N instead of a number to designate substituents. So substituents off of the nitrogen are designated as, and I'm going to put it in quotes. Obviously, we're not going to write substituent in the name, but it would be like N-methyl or N-ethyl, N-isopropyl. But you put a capital N in front before the parent name. So you start your numbering at the carbonyl carbon, name it as normal. If there's anything off of the nitrogen that's not hydrogens, you have to put an N instead of a number. So I have two examples here. I have two examples, so I'm going to kind of split this box in half to show you two different examples. 1, 2, 3, 4, 5. Then NH2. So here's one of the examples. And then the other one, I'm going to make sure that I show you what it would look like if, like this, if there's something off the nitrogen. So when it comes to numbering, I'm going to look at this top one first. Your numbering always starts at the carbonyl carbon. So 1, 2, 3, 4, 5, 6. That C double bond O NH2 is the amide. That doesn't count as a substituent. That identifies the parent chain and the ending. If this were all single bonds, what would this be? Hexane. When it comes to the ending, you just drop the E and add amide. So maybe we could add that in here in terms of the ending. All we're doing is dropping the E from the parent chain. Meaning if it were hexane, it'd just be hexanamide. So this, again, hexane, there's no substituents. So this is hexanamide. Now the second one, I want to show you the second one just because there is something off of that N. We have to see how we would designate that. So we're going to have numbering in two places. I'm going to start the numbering at the carbonyl carbon. 1, 2, 3, 4. The side with the carbonyl carbon is what determines our parent chain. For a carbon carbons all single bonded together would be what? Butane. You just drop the E and add amide. It would be butanamide. So the parent name would be butanamide. Now, that's not just our name, because notice that we have something off of the nitrogen. Now, if you had, like, let's say you had a methyl group off of carbon 3 over here, then you would have 3-methylbutanamide. If you look at that intro to functional groups sheet from Monday, it shows some like that. It shows lots of different molecules. Now, over here, we have 2 carbons connected to the nitrogen. 2 carbons is what substituent? Ethyl. Now, because it's connected to the N, it would be N-ethyl butanamide. You just treat that N as if it were a number. Right? So this would be N-ethyl butanamide. It's all one word. Because we're treating that as if it were a number, there is a dash between. Because you're telling the location. And again, we'll continue to look at the practice with that so that you can see what it looks like. Okay, so then the next one is an aldehyde. How do you tell something is an aldehyde? What do you always look for? H to the side. So you have to have this hydrogen off to one side. It's that carbonyl carbon with the hydrogen to one side. The ending for aldehyde is Al. It's like methanal, propanal. Make sure you can tell the difference between your A's and your O's. We're going to look at an OL ending as well. So when it comes to naming aldehydes, the aldehyde is part of the parent chain. And just like everything so far, what number has the carbonyl carbon been? 1. Right? It's given number 1. So then you're just going to start at the aldehyde group and work out. Okay, that's supposed to be aldehyde group. Same thing. It's just the E that gets replaced. A lot of these you're just replacing the E. So instead of butane, butanal. So an example, I'm going to scoot this over so you can still see the rules. Let's look at this example. We'll do Cl. And then do this. The first thing you're always doing is you're looking for your longest parent chain. The aldehyde, the carbonyl carbon within the aldehyde gets the number 1. Always, no matter what. You work out from there. So if we're looking at the parent chain first, 4 carbons is what? Butane. Drop the E, put Al. Butanal. Are there any substituents? On what carbon? 4. What's off of carbon 4? Fluoro. So it is 4-fluorobutanal, all one word. All of your substituents, right, just like normal now, if you had chloro and methyl, Then chloro would come before methyl because of alphabetical order. Okay, then we look at ketones. So notice how all of these so far have had carbonyl carbons in them. Helps to give priority. So a ketone. You distinguish a ketone because of that carbonyl carbon. Notice how it was a more complicated molecule with the carbonyl carbon, and we're working our way down priority, and now all we have is that carbonyl carbon. The ending for a ketone is O-N-E. So ketone, I give that own ending. Naming a ketone. Okay, start from the side of the parent chain that gives the ketone the lowest number. So now we do have to look at which way is better to number. So you need to make sure that you're giving the ketone the lowest possible number. If it's right in the middle, then you go to your substituents. What would give your substituents lower numbers? Okay, if there's more than one, so actually let's do this first. From the parent chain, drop the E, and add O-N-E, right, O. If there's more than one ketone, which we could see, more than one of those carbonyl carbons, then we just add a prefix before the O-N-E suffix. So like dione, trione, just like we did with diene and triene. So when it comes to ketones, we want to give our ketone the lowest number possible. So let's look at there's our double bond O. Let's do this. Now when you start numbering, should you start numbering from the left or from the right? Start numbering from the right. That's going to give your ketone the lowest number. 1, 2, 3, 4, 5. It doesn't matter which way you go because there's only one carbon either way. So 6 carbons, all single bonded, would be what? Hexane. You drop the E and add O-N-E. So the parent name here would be hexanone. Right, the parent chain there would be hexanone. Now you do need to be able to distinguish where that ketone is. Kind of like you did with the alkene. What carbon is the ketone on? 2. So the parent chain here is actually 2 hexanone. Are there any substituents? Yes. Off of what carbon? 5. So we'll do 5 methyl 2 hexanone. Now, if you are someone who liked writing the alkene number in the middle, it would be the same for this. Here's what that would look like. It would be 5 methyl hexan 2 O. Alright, 5 methyl hexan 2 O. No space between the methyl and hexane. Let's do just one more. Let's look at an alcohol, right? And then we just have the amine and the ether. Maybe we can get through all of them real quick. So alcohols. This is why it's really important that you can distinguish between your O's and your A's. Right? An alcohol is just some carbon group, but you have that OH attached. Notice now the carbonyl carbons are gone. Now we just have some OH group. The ending for an alcohol is OL. You see alcohols all the time. Ethanol, methanol. You used those yesterday. Those are alcohols. When it comes to naming alcohols, this is another one that we see prefixes with. So when it comes to naming, the parent chain must include the OH group. Right? The parent chain must include the OH group. Give the alcohol, the OH, the lowest number possible. So now there's not one side that we have to start with. You just need to make sure that your alcohol, your OH group, has the lowest number possible. We have to make sure that we denote the location of the OH group. Which means we need to tell the location of the OH group by putting the number in front of the parent name. So like 2-pentanol tells you that the alcohol is on carbon 2. Then we just need to use prefixes if there's more than one alcohol. Use prefixes in front of OL if multiple OH groups. You do need to add an E when using prefixes. I'll show you an example. So I'm going to show 2 examples just really quick. So, first example. I'm going to draw the alcohol backwards, actually. Okay, here's one of them. And then here's another one. Oh wait, this is supposed to have, there we go. Okay, so here are 2 examples. Let's look at the double alcohol first. You need to number it so that your OH groups have the lowest number possible. Check both ways. Your parent chain should have both of those OH groups. I could start down here. 1, 2, 3, 4, 5, 6. So it would be 2, 4. Or 1, 2, 3, 4, 5, 6. 2, 4 or 3, 5. Which numbers are lower? 2, 4. So 1, 2, 3, 4, 5, 6. Because there are 2 OHs, it becomes a diol. What is 6 carbons? Hexane. The parent name of this is hexane diol. All one word. So it would look like, let's see, 2, 4, hexane diol. That's the parent chain. You have to denote where the OHs are. They're on carbons 2 and 4. Are there any substituents? Yes. Off of carbon 5, we have a methyl. 5-methyl 2,4-hexane diol. If If you want to name it the other way, it would be 5-methylhexane 2,4-diol. If you put those numbers in the middle. Then if we number this way, look at the second one. 1, 2, 3, 4. Your OH takes priority over any other substituent. Give it the lowest number possible. What's 4 carbons? Butane. So it becomes butanol. So to name this, it would be 3-methyl. And you could do 1-butanol, but if you just did butanol, you just did 3-methyl-butanol, that's telling us it's on carbon 1. Yes. Okay. So we have the last 2 functional groups that we need to finish with the naming rules and then looking at the example molecules. We went all the way up through the alcohol yesterday. Remember that with these molecule types, they are in order of priority. So a lot of what we looked at yesterday had the carbonyl carbon in it. Then we got to an alcohol, right, where the carbonyl carbon isn't there anymore. So same thing with the other ones today. So we're going to first look at an amine. So yesterday we looked at amide. Today we're going to look at amine. So an amine is some R group bonded to NH2. So you're going to have nitrogen single bonded to some carbon group. Difference between amine and amide, we don't see the carbonyl carbon in amine. So amine is just the R and H2. The ending is just, nope, not amide. Amine. Here we go. Right, the ending is amine, like the amide, but the ending is just going to be amine. Now, in terms of naming, naming rules are similar to an amide. So we're going to number, I'm going to try to write this small, the longest carbon chain that includes the amine. Right, so we want to prioritize the nitrogen. This means that one of the carbons in the longest chain needs to be connected to the N. The N is not necessarily in the longest chain. You need this carbon must be within the longest chain. Right, so then when we're naming, if there are substituents off of the nitrogen, add N with the substituent name. Before the parent name. So you can use N like a number if you have something off of the nitrogen. Right? If there are multiple nitrogen groups, so if there are multiple nitrogen groups, we can actually write the N with a superscript. Right? A superscript is like up in the top, like an exponent, to show the position. So an example might be like N2. It's not N squared. You're just saying it's off the second nitrogen. Like always, if there are multiple amines, we just use prefixes. as well. And so I'm going to put 2 example molecules over here just so we can see 2 different examples. So I'm going to kind of split this in half so we can see 2 example molecules. Let's say I have an H, do NH2, and let's do a methyl group. Alright, so something that looks like this would be our first example molecule. Then I'm going to draw the second example molecule, and then we'll work on numbering and naming them both. So we have 2 example molecules here. We're going to look at following these naming rules to actually name both of these. I wanted to show both because I did give you one that there are 2 amine groups. So what would it look like if we had to name something with 2 amine groups versus just 1? So if we look at this top example molecule, we're looking at numbering. So we want to number the longest chain so we can prioritize the nitrogen. So we want to give the carbon connected to the nitrogen as low of number as possible. So if we look at this, it doesn't actually matter which way we go. We could go 1, 2, 3, or 1, 2, 3. Right, the longest chain is actually 3 carbons here. If you say, well, why not this carbon over here? Well, because you've broken the carbon chain. This is a nitrogen, not a carbon. So, if we kind of start with the parent name and we work our way back, what is 3 carbons all single bonded together? Right, propane. So, we kind of keep that in mind. Notice that there are 2 amine groups. There are 2 nitrogens here. 1 here, 1 here. What's the prefix for 2? Di, and then your ending is amine. So your parent name here is propane diamine. All one word. We do need to tell where the amines are located on this carbon chain. The nitrogens are off of what 2 carbons? 1 and 3. So our parent chain here will be 1, 3 propane diamine. That's all one word. Remember that we include the E's when we have our prefixes like di or tri. So that's our parent chain. Now, do we have any substituents off of this? What's one of the substituents? Methyl where? Okay, on carbon 2. Do we have any other methyl groups? Off of N. Right, off the nitrogen. So we have 2 methyl groups. So like always, it's dimethyl, which means we need 2 numbers. Now, in this case, we're not going to have 2 numbers. We're going to have a number and a letter. The way that we would actually number this would be 2N dimethyl. So 2, N dimethyl 1,3 propane diamine. So instead of like 2,2-dimethyl or 2,3-dimethyl, this N just takes the place of a number. You're saying that it's off of the nitrogen. Then dashes, right, between our designations, just like we would normally have. Diamine means we have 2 nitrogens. Now if we look at this other example molecule, right, we're looking at our parent chain. So we number to prioritize the carbon connected to the nitrogen. The nitrogen is not part of the parent chain itself. The carbon connected to the nitrogen is. So this carbon right here should be part of the parent chain. So you just have to figure out, should I number it from left to right or right to left? You want to give it the lowest numbers possible. We're going to go from left to right. 1, 2, 3, 4, 5, 6. 6 carbons, all single bonded together would be what? Hexane. When you don't have a prefix, you just drop the E. So our parent name here would be hexanamine. So parent name here would be hexanamine. You do want to tell where the nitrogen is. So what carbon is the amine group off of? 2. So the parent chain is 2-hexanamine. Any substituents? Maybe not off the parent chain itself, but we have something off the nitrogen. Off the nitrogen here is a methyl, which means that our prefix would just be N-methyl 2-hexanamine. Now, amines are one of the lowest priorities in terms of being the parent chain. Before we're completely done, we are going to look at what it would be named if it were a substituent instead. We see amines as substituents more often than as the parent chain. Okay, so the last functional group that we're going to look at is an ether. So an ether is an oxygen single bonded to 2 carbon groups. The ending of the name is just ether. Now, an ether is a little unique because an ether actually has 2 parent chains. You have a parent chain on each side of the oxygen. So, with the naming rules here, oxygen is the center. And there are 2 parent chains. So oxygen is right in the middle, and there are going to be 2 parent chains. The carbons, because there are 2 parent chains, we're going to have 2 number 1s. So the carbons closest to the oxygen are number 1. So when it comes to numbering your parent chain, carbon 1 is always the carbon attached to the oxygen. And then you number out both directions. When it comes to naming, we alphabetize the parent chains. And I'll show you a couple examples so you can see what I mean by alphabetizing the parent chains. We separate the parent chains with a space. So in terms of naming, there's actually going to be a space between the 2 parent chain names. And then you always add your substituents before the parent. So additional substituents are listed before their parent chain. That's just like a normal alkane. So I'm going to show you what this would actually look like because I think when you see it, it makes a little bit more sense than when you look at the rules. So one of the example molecules, we'll do this. Oh. We'll do this. So we start with numbering. All right, we have two parent chains. So carbon 1 is always the carbon single bonded to the oxygen, and then you look for the longest chain. So I numbered starting with 1, and I worked my way to the left. There's one of the parent chains. The other parent chain is here. Now, what is 4 carbons? Right, so butane. 2 carbons is what? Right, F. So we have but versus F. But will come first. So we're going to actually do the pink numbers first because that comes first alphabetically. Now let's just name this like normal. Let's ignore this oxygen, act like it's not here, but use my numbers that I put there. So just looking at what I have right now, how would we name this? Okay, 1,2-dimethylbutane. The only difference is that drop the ANE and make it YL like it's a substituent. So 1,2-dimethyl-butyl. 1,2-dimethyl-butyl. Right, we're not done yet, but that's the first part. That's the first parent chain. It's a substituent off of the ether. Okay, let's act like this part's not here. What's 2 carbons? Right, ethyl. All right. So I'm going to put a space between my 2 parent chains. It's ethyl. Because yes, these are 2 parent chains, but they're substituents off of the ether. Now the last part of this name is you just add ether. So 1,2-dimethylbutyl, ethyl, ether.
When it comes to the amines and substituents off of the end groups, do we have to specify which end group has the substituent? Because I know in that problem itself, it doesn't really matter, but when it does,
If it does matter, then yeah, you should.
Do we have to put it in parentheses, or do you just put the
You
number?
could just do the number. Yep, just the superscript.
Is there a space between ethyl and ether?
Yes. Yes, so you'll have basically every color here, there's a space in between. So just kind of a general example, and you just might hear this often, especially in organic. So that's an ether, right? There's carbon in the middle, 2 substituents on each side. What is the substituent on the left side? Methyl. What's on the right side? Methyl. Well, instead of saying methyl, methyl, ether, this is actually dimethyl ether. You also might hear of diethyl ether. If it's the exact same thing on both sides, you can actually use prefixes that way as well. Now, one thing that might be useful, just as I'm sure people will start asking, like, what happens if something is a substituent instead of the parent chain, right, or the priority? So I want to look at just a few of these and see what if they're substituents instead. So over here, really, really small, I'm just going to write if a substituent. If a substituent. Meaning, what if that's not priority? Okay, well, I'm not going to put it for carboxylic acids or esters. Even, we're really not going to do anything until we get down to ketones. Because usually if we see one of these up here at the top, it's probably already priority. If a ketone, so let's say that you have a ketone within a carboxylic acid. All right, let's say a ketone is down the carbon chain, but you have a ketone within a carboxylic acid. As a substituent, its prefix is actually oxo. So if you had a ketone on, say, carbon 4, it'd be 4-oxo, and then you would continue, just like methyl or chloro or bromo. So the first 4 we don't really see. Alcohols we sometimes see. As a substituent, an alcohol is actually a hydroxy or hydroxyl group. Right? Sometimes you see it as hydroxy. Sometimes people add the L, just so you recognize that you might see both of them. And then amine might be the most common one that we see as a substituent. We talked about this a little bit in AP. It's actually amino. That's an O. So you might have like 4 amino, 6 chloro, nonane, something like that. An amino is when you have an amine that's a substituent. For the most part, we're just going to focus on what happens if this is its priority. But there's always questions on what it might be if it's a substituent. Okay, so what we're going to do is we are going to look at these slides that are in your notes. This is actually practice. So you'll see that it says the answers can be found at this link. We're going